are some fonts that have, I don't know, like all these different weird Unicode variations on the letter A, right? And so you have thousands of outputs to your network. And understandably, it's going to be much harder to make accurate predictions on all these. So that might be something to look at. Look at the size of your alphabet for the fonts you're working at. And it could be that your accuracy issues are explained by just solving a really hard problem. So I think like the kind of standard fonts are probably more likely to have all these weird variations, whereas some of the like more obscure ones, they didn't bother to do it. So yeah.
For different fonts with the same characters have the same end label? Is that how we?
Yes, the end label should be the Unicode code, which should be the same for all of them.
That's how we can filter to train and test on different.
Yeah, yeah. The end labels, I believe, are the Unicode representations. Okay, so we're going to continue to work on our graph visualization tool using V3. Today we're going to add some interaction and actual graph drawing. Yesterday we got to the point where we could draw text at random places, which, while being very cool, is probably not the most useful of visualization tools. So today we're going to add on user interaction, actual graph rendering, and we're even going to do a little bit of force-based layout. So that's the plan for today. So just to give you a preview of what things are going to look like eventually. So I've got my Kevin Bacon and some co-stars from some of his movies. And we're using a force-directed graph layout, and I can actually I can interact and manipulate the node positions. Okay. So that's where we're headed. But just to remind you where we're at. This is where we were at the end of class yesterday. So still extremely cool, but not quite its full feature. All right, so just to refresh our memory, what we were looking at. So we had we loaded our Kevin Bacon movies over Ajax. Then we processed the data, so we did JSON parsing of all the movies. We found out who all the actors were, and then we used D3 to make DOM elements for each one of our actors. So we have this weird thing where we select all the paragraphs, even though when we started there were no paragraphs. And then we said for any new paragraphs, we're going to actually make the paragraph element, and then set the text and add our click handler so that we can select stuff. Our click handler, we we toggled whether this actor was selected or not. So we used the classed thing to add or remove a class. And so the CSS made stuff with this class turn blue. And then we did update circles, which was going to, we don't have any circles yet, it's just text, but okay. And so what this did is we got all of the actors that were selected. So we're just using a CSS selector here. And then we made a text element for each one. So again, this is the G3 pattern of selecting the optimistic selection. Okay. Although this time, most of the text elements are actually already going to exist, right? Because we're just adding one new actor or removing one actor. Okay. So we're selecting all the text elements. And any new elements that we're creating, we're making a text node, and then putting it in a random position. Any ones that already existed, we're just going to change the text color to green. And that's where we're at. So any questions about what we did yesterday? To do the graph with like circles and text together, there's not an SVG element that has both of those things in it. So we're actually going to have to draw two different things per graph node, and we want those things to kind of be linked. We want them to have the same position and be associated with the same data, right? So the circle for Tom Cruise and the text for Tom Cruise should be related. Okay. And the way we're going to do this is we're actually going to use an invisible SVG element called the group. Okay, so for each actor, we're going to have a group element, and then the group element is going to have a circle and the text element in it. And we're going to attach all of our data to the group element, and then we'll update the when we draw the other elements, we'll update it based on the group's properties. Okay. So we're going to make kind of a refactoring change first. We're actually going to store a little bit more data about our active nodes because we want to keep track of their position so that we can let the user interact with them, and also so that we can use them for simulations later on. Okay. So what we're going to do is we're going to change basically this part, so how we know which actors that we're working with, so that we're kind of future-proofing our code. Okay. So we're actually going to make a change here. So we're going to explicitly keep track of which nodes are currently being drawn, and then we are going to explicitly update that when we toggle stuff. So after I do this toggling thing, I'm going to look and just see if I'm currently selected or not. So if I am, yeah.
I was just, we have to add a launch with or is it okay?
I posted the stuff from yesterday, so I'll post this again. If this node is now selected, right, then I should be adding it to my list of active nodes, and otherwise I should be removing it from my list. Okay. So. So the node, I'm going to store the name of the actor, and then I'm also going to store its position. So my node object is going to be a JavaScript object with 3 fields. I'm going to have the name, the X, and the Y. So I'm going to move some stuff around. So I'm going to assign the X and the Y when I create the node, and then we'll mess with it later. Okay. But I'm going to make a new object. So the name is going to be the data that I'm dealing with, which is the name of the actor. And then we'll set the X to be a random X position. We'll set the Y to be a random Y position. Okay. So now we've added to our active nodes. Cool. If I am now unselected, right now I have to remove this node from the list of nodes that I had before. To do that, I'm going to use the array filter function. And then this takes, I can take a lambda function, and I want to basically keep anything I want to keep all of the other actors, right? So if the name is different from this actor that I just clicked on, then I'm going to keep it. So I'm going to look in the name field and keep the ones that are not there. Cool. Yeah. So I basically replaced this part here where I'm using the CSS selector to know to get my actors that are active. I'm explicitly keeping track of that data myself, and that's because I need to store some more data. So I need to store the positions of the actors. I could add that data to this, like the list of all the actors, but I have like 150 actors, and I'm not going to render very many of them. So I don't really need to give X and Y positions to all of them. I'm just going to pick X and Y positions for the ones that actually get drawn. Yep. All right. So yeah, any questions about that? Yep. So now in my update circles function, things change a little bit. This selected actors, so the way that I get my data is I don't need that anymore. And now the data that I'm going to the data that's associated with my nodes is this array that I was just that I'm keeping that I'm updating on the clicks. So this is the data that's associated with my nodes, and then the way that I get the ID, the key for each node, is a little bit different. So each node, I basically want to be associated with the name of the actor. So I'm going to dig into that object and pull out the name field. So that's how I can tell my nodes apart. I can tell which node is which by looking at the name field. Cool. So, and then everything else is the same. And so this should do exactly the same thing that we did before, just refactoring. And let's see what I screwed up. And it looks like nothing. Cool. All right, so same thing we did on yesterday, but we're structured in a slightly different way. Now we're storing our data as an array of objects that have some more information with them, and then we can manipulate more stuff with them based on that. Cool. All right. So next thing, let's add. Text is great, but let's modify this so that we're actually adding circles and text together. Yeah. And so, as I mentioned, we're going to use the SVG group element. That's going to be what we attach our data to. And then the group element is going to have a child for the circle and a child for the text. And then we can update all that stuff together. So, I'm just going to have a couple of just have the constant here because we'll use this in a few places. But so we're going to have to mess with what we have here quite a bit. So the first thing is for all of the nodes that I want, I'm no longer making text nodes directly. Now I want to make group nodes. So this part is going to change. Okay. So now the nodes that I'm selecting and creating are going to be groups instead of text elements. Okay. And I'm going to get rid of this transform part as well. Okay. So I have this this group, and yep. This is a SVG thing. So it's a SVG element, you can use it to put a bunch of like shapes, group them together, and then you can transform them all at the same time if you want. So you can do like rotation and flips and stuff on a whole bunch of elements at once. We're basically only going to use it as a data container. We're not going to do any transforms or anything with the group, but you could do that.
Position is not considered transform.
Position is a transform. So the translate is like the simplest of the transforms. But you can do translates, rotates, scale, shear, all that sort of stuff. And yeah, group will apply it to everything inside. So we have a group element that we're creating, and then we want to add to that group element a circle and some text. Okay. So we'll start with just the text. So again, we'll get basically the same behavior that we just had with slightly more code. So I have my group element, right? And then within that group element, I want to put text. So I have my group element, and now I want to append a text element. And then that text element should have the text, which is the actor's name. Does that kind of make sense? So I just added another layer here. So I put my text inside of a group. Okay. And then my update has to change a little bit because my group doesn't have a fill property. Group is like an invisible thing, right? So what I actually want to change is the text color inside of my group. So now I have to select. So my update is going to be groups. When I select this, I get the text that is a child of that group, and then I can change the text fill color. So hopefully it didn't break anything. And again, everything works exactly as it was working before, but we have some more code. Okay. And if we look in the inspector here, change. I did break something. So I do have my group with the text in it, and all of the text, you can't see it because it's all positioned at 0, 0, which is just outside the viewport because I didn't set what the position should be. So let's go ahead and we'll fix that. So our text, there's attributes for X and Y. And so what I'm going to do is I'm going to set the X part of the text to be the X field of my data. And my Y field to be the Y part of my data. And so now this should work a little better. So again, we have now written more code to do the same thing. And if we look inside of our SVG elements, we have now a group with text in it. Cool. Any questions so far? Okay, we are about ready to get to the interesting stuff. So now we want to add circles. Okay. What do we want to add the circles to? To the group, right? So if I just tried to stick a pen here, right, what would I be adding them to? Be adding the circles to the text. My text can't have children, so we don't want to do that. So what we're going to do is we're just going to save. We're going to save the groups in a variable, and now we can use the groups both to add text and to add circles. So the circle, we'll fill these in white. If I don't do a fill, then if I have like a transparent thing, then it makes it more of a pain to click with. So I'm just going to make it white to make things a little bit simpler. Let's we'll make the stroke blue, so we have a nice blue outline. And then we'll set the position. So the circles, instead of having X and Y be the position, SVG decided they should be called CX and CY. And again, so I'm just going to copy and paste here. So the position of the circle is again going to be the X and Y from the data that is associated. This is kind of a little bit weird. There is no data associated with the circle. The data is associated with the group element. But so as a child of the group element, I can access the data of my parent. So that's kind of what's going on here. Cool. So everybody happy with this? Ready to see some cooler pictures? Here we go. I have a very exciting circle that is of size 0. Okay, so let me set the circle radius. So now we're going to use that constant I made up here. And here we go. So, looks pretty great with a couple of exceptions. Right? What problems do we see here?
It's overlapping here.
Probably why you're balancing based on the radius and circles.
So my circles are on top of the text, so they're hiding all the first names. So that's an easy fix. Just put the circles in first. So cool, that's a big improvement. And then the other problem is the text is put in the circle center. Right. I could do something, clever to do the positioning. I'm going to do just the dumb thing, which is my text x coordinate. I'm just going to subtract off the circle radius. So we'll start. The text will just start on the left side of the circle, and we'll hope that it fits. And it fits pretty well for a lot of the actors, actually. Evan Rachel Wood, not so much. But this is much a big improvement over what we had. Cool. All right. Cool. So everybody happy with this? Okay. So maybe the next thing we want to do is we want to actually interact with this. So the next thing we'll look at is how we can drag stuff. There's a built-in thing in D3 that can help automate this stuff. And so this is called drag, and it has events for when you start dragging, while you're in the middle of dragging, and when you stop dragging. And so we'll write some callbacks for those. This call function basically calls whatever function is in here on the current selection. So it's going to call, so this thing returns a function, which is weird that a function returns a function, but it works. And so that is going to get called on all of my group elements. So the way this drag works is I just say, okay, on so we're just going to put callbacks for 3 functions. So we'll have drag started, dragging, and drag ended. And so this is going to basically attach listeners to all my elements for these events. Okay. And then we'll go ahead and we'll fill in all these functions below. Okay. And so maybe just as just a test, a sanity check. Just going to print out what I'm dragging. So we can see what's going on. Nothing is going to move because we haven't said like how to update any of the positions or anything. But we're just going to get these when the mouse events for associated with the dragging. So mouse down and then movement with the mouse down. So we should get these events. So let's go ahead and look at that. Go to the console. And you see I am dragging my circle with Tommy Satura in it. I drag that one, I get that I am dragging John Lithgow. And see, I get the started dragging first, and then I get the rest. Cool. Maybe the first thing we can do is when I'm dragging something, I'd probably like it to be like on top of everything. So we can raise elements. So I'm going to grab the D3 wrapper around whatever I'm dragging, and I'm just going to raise it. So now I should be able to pull that to the top. So, good. Go until we get some overlap. So now if I start dragging one of these, it moves to the top, which is kind of nice. And then the next thing I need to do is to update the positions of stuff as I drag it, so that they actually get dragged. So what I'm going to do in here is I'm going to update my my data, X and Y, And then I'm going to use that to update the DOM elements that are associated with it. So JavaScript, I think we've talked about this. You can get the wrong number of arguments to a function and it doesn't matter. So if your function takes fewer arguments than are passed, you just don't get them. And if you take more than were passed, then you just get undefined for the ones that weren't there. So all of these, D3 is going to pass the associated data, but I was just ignoring it for the other ones. So here I actually do care about the data, so I'm just going to indicate that I'm taking it as a parameter. So I'm just going to update the X position, the D3 like mouse event stuff that's happening keeps track of where the mouse is. So I can just grab that out of the event that's going on. And then I just need to update the text and circle positions. So maybe let's do the text first. So first off, I have to grab the text elements. So any thoughts on how I can do that? So first thing, I'm going to grab this. And what type of node is this going to be? It's going to be the group because my drag stuff is associated with the group. Right, so now I have my group. And now I can grab children of that with select. So I'm going to grab my text child. And then I can set the attributes. Okay. So let's see if that works before we copy it and try to use it for the circle as well. So now if I drag the group, the text moves. I think if I drag, yeah. So the group is everything that's in it. So if I drag the circle, it still moves the text. Cool. So we'll do the same thing for the circle. So now we're going to select the circle. And now the attributes are called CX and CY. And then we're going to remember that we wanted to keep this offset there so that the text stays on the left side. So that's going to be so let's give that a shot. Okay. And now we can drag our nodes around. And again, when I unselect them, they disappear. Cool. All right. So, questions so far? So this may be a little bit tedious, right? Because we're having to be pretty explicit about all the interactions we want. But as GUI programming goes, this is not so bad, right? If you remember when we were doing the Java FX stuff last fall, I think that was a lot more code, a lot more, just obnoxious stuff. One thing I really like about working with SVGs is I have the visual representation here, but I can also look directly at the elements, right? And so I can figure out oh, that element is there, but these properties were, I screwed up my positioning, or the color is white, or the radius is 0, stuff like that. Whereas like if you just have a canvas and it's like my thing's not there, like it's much harder to debug. I find that SVG is a really friendly way to work with. It's also human readable, right? You can print out the SVG file and just look through it. You can grep it, all that stuff. So I think anytime I'm working with GUI stuff, SVG is kind of my go-to. All right. We're doing graph rendering, graph visualization. So what's missing? Edges, right? So we got the nodes. Nodes are looking great. So now we need some edges. Okay. Edges were, I don't know, found to be a little bit more complicated, but we'll go ahead and add them in. Okay. So the way that I'm going to store my my graph with all the edges is I'm going to store a dictionary where the keys are going to be an actor, and then the values are going to be all of the movies that they've been in. So there's going to be edges for all the co-stars. So I'm going to have a start with this empty object, okay. And then as I load my data, I'm going to fill it in. So when we did Python, we could kind of let the iter tools help us out to figure out what all the edges should be. Here we're going to do it manually, and we're actually going to store all of the edges twice. Why would we do that? Why would I want to store all the edges twice? Yeah, so I'm going to, since I have a dictionary keyed on each node, so for rendering it doesn't matter so much, right? If I have, I loop over all the edges and all the nodes, right? Then I'm going to see all the edges, no matter which, side I store it with. But if I want to do like pathfinding, or if I want to do my 6 degrees of separation stuff, right? Then I need to be able to get all of the edges out of a node efficiently, right? And so storing the edges twice seems to be the way to go there. I think that's actually what NetworkX does as well. So it might store like an index to an edge in both places or something. But, yeah. And so we're just going to duplicate it, which means that instead of looking at all the combinations of actors, I'm actually just going to look at I'm just going to do a nested loop of the actors and do the edges that way. So I'm going to replace what I have here. I'm just going to loop through twice, and I'm going to start at 0 both times. And then if j is not equal to I, then I have an edge. So the first thing I'll do what I did before, so I'll add this to my set of actors. Get rid of this code here. Okay, so for each actor in the movie, I'm going to add it to my set. And now I have an edge to add. To add an edge, basically I just, if I've already seen this actor before, I'm just going to add a new entry to an array. But if I haven't seen the actor before, I need to make an empty array first. So first I'll check to see if I've seen this actor before. So if this actor is already in the graph, actually, anyway, so if I have not seen this actor before, I'm going to put an empty array in my graph. And then afterward, I can just append this new entry to that array. Okay. So I'll just put an object with two fields. So the actor on the other end of this edge is going to be actor J. And then I'm just gonna, the movie is gonna be my movie title. So looping through all the other actors. If it's a different actor, I'm gonna add an edge from me to them. And since I'm looping through twice, right, everybody should get an edge to everybody else. Cool. Any questions on this? Maybe at the end of this, just see what's in our movie graph. That's another nice thing about working in the web JavaScript framework. The console output, like, you don't really have to think too hard about formatting or like, am I going to dump too much information, because the browser does a really good job of grouping repeated data together and letting you look at objects in as much or as little detail as you want. So that's another thing that's pretty handy. So if we look at our movie graph, we see that Kevin Bacon has 174 edges. So he's been in, so Alec Baldwin has 3 co-stars in the list, and they're all from She's Having a Baby. Cool. So now we've got our graph, so we can start to do draw the edges in our graph. Cool. All right. Questions so far? All right. So thoughts on where we should put code that deals with edges? When do we want to think about edges? During movement. So we'll update positions during movement. Yep. So we'll have to mess with the drag stuff eventually.
Yeah.
When I'm changing the nodes, right? Right. When I change the nodes, I might be changing the edges. So what we're going to do, we're only going to draw the edges associated with nodes that are being drawn, right? And so once we know what the active nodes are, then we can figure out what the active edges are. So that's going to be here. So I'm going to add another array for my active edges. So how do I know which edges should be active? So both actors should be in my active nodes, right? So how can I find those edges? So I can loop through my active nodes, right? And then I can use my graph to find out all the edges coming out of those nodes, right? And if my if the other endpoint is also in the active nodes, then we're good. Okay. So we're going to set our active edges to be empty. Then we're going to loop through the movies. We're going to loop through the nodes. And then we're going to look at the edges in the graph associated with that actor. We'll have for each edge, which is going to be our movie graph for the actor with that name. And then, if the other end of that edge is also in our active nodes, then we should add it. So we use the includes function, and it can take a function that says like whether or not these things are good or not. So if our active node includes an object whose name is the actor we're looking at for this edge, kind of roundabout way here, but yeah. So I think it includes. Yeah, I call it includes, and you can take. Sorry, I think it's find. When I want to pass a function, it's called find, I guess. All right. So if I find that actor, then I want to make an edge. So this is going to result in doubling all of my edges, right? Because I'm going to find an edge both ways. Right? Any ideas how I could change my condition here to not do that? How can I pick one of the two options for the edge here? So the solution I came up with was I'm going to force my edges to be alphabetical. So I'm just going to check to see if my if the N comes before the actor from E in the alphabet, and if it does, I'll include it. If not, I won't. So I'm going to add a test here. So if N.name is less than E.actor, and the other actor is also in my set, then I'm going to do these edges. Cool. And then the edge struct, or the edge object that I'm going to make has to have a particular set of fields to work with the simulation stuff in D3. So we're gonna name it based on that. So so the edge I'm going to make is going to have a source, a target, and I'm going to store the movie name just so I know. So that's just, you know, in case that information is useful for me later, but the source and the target are required to have. And so I could store the names of the actors here, which makes sense and it's kind of logical. But what I'm doing, if I just stored the names here, and I'm like drawing my edges, I have to know the positions of the nodes of the attack that they're attached to, right? Does that make sense? I'm actually going to be a little more clever here. I'm going to store the node object. So I'm going to store basically a pointer to the actual node object that has a position, right? And that's going to make my life a lot easier later on. Okay. So what I'm going to store here is not the name of the actor. I'm going to store my source is going to be my actual node. Okay. And my target is going to be the node for the other actor. Okay. That kind of makes sense. So now I can, from one of my edges, I can get the endpoints of the edge right away, not just the names of the actors, but the actual data points with position and everything, and that's going to be really helpful. Cool. So to start with, let's just see what edges we're coming up with, and see if this is working. Cool. So if I pick two people that aren't in the same movie, so Tom Cruise and Frankie Muniz, I see that my active edges are indeed empty. I toss Kevin Bacon into the mix. Now I have edges from for My Dog Skip, which Frankie Muniz was in, and A Few Good Men with Tom Cruise. And you see the source and the target are not just the name Frankie Muniz, it's the object for his node with position and all that stuff. So if I drag this around and then add a new actor and I look at the Frankie Muniz one again, the position actually changed. So the position reflects the dragging. So I'm storing a reference to the actual node data, which is pretty nice. Cool. Good. All right, everybody happy so far? All right. So now we have this data. It's in a good spot. So now we're actually going to draw the edges. Okay. So we're going to go to the same spot. So here, when I'm making all my group elements, I'm also going to make all my line elements. And so that the circles are drawn on top, I'm going to draw the lines first. So you can do the same thing. I'm going to grab my canvas. I'm going to grab all my lines. Again, the first time I do this, there won't be any line elements, but I can adjust that. If I wanted to put the movie along with the line, right, I'd have to do the same kind of thing where I'd have a group with the line and a text in it. But here we're just going to draw the lines, keep it simple. All right. And then what data do I want to attach to these lines? It's going to be my active edges. And so each one of these edges should have a line element associated with it. And then this is kind of a tricky thing, is how do I recognize a line? I need some unique name for the line. And so the solution that I came up with is I'm just going to take all of the three fields and just add them together. So I'm just going to take the way I get a unique identifier for the line is I'm just going to take the source, the target, the movie and just concatenate them together, and that's going to be a unique identifier for this movie. So this way D3 doesn't, confuse which line is which. All right, and now I'm ready to talk about what happens to the nodes that I create and the nodes that I update. Okay. So for the graph edges that don't have a line associated with them yet, what do I need to do? If I don't have one yet, I need to append. Okay. And I'll set some properties. Make them gray. Actually, I'll make them kind of thick. And then for my for the updated ones, so the edges are gonna pop a little bit when I add them, and then they're gonna shrink down a little bit. So I'm gonna set my stroke width to 2. So after, if I've seen them before, I'm gonna shrink them down a little bit. Another thing you can do with D3 that maybe we'll look at next week, you can add transitions. So one thing you do is when you make a new element, you can set it to be like brighter or thicker at first, and then transition to a more muted look. And so it'll happen over time as opposed to like when there's updates. So that's another option. Right. And so this is cool and all. If I drew this, I wouldn't see anything. What am I missing?
Your calls.
To so I have the line element, but it's going to be in the SVG. If I looked at the DOM, I'd see it, but I won't see anything on the screen. The reason is the position of my line. The 2 endpoints are both going to be at 0, 0. So now I need to actually set the position of my endpoints. So the attributes for that are x1 and x2. So what should the x position of my, one of my endpoints be? So it should be the x of my source. And this is where storing a reference to the node in my edge is going to really pay off. So d.source is not just the name of the actor, it's the actor's node. So I can actually just grab the x out of it, which is pretty handy. And then I have the same thing. I have x1, y1, x2, y2. So I have my x1, x2, y1, y2 are just the source and target positions. All right. So now when I add new nodes, I should get the edges between them. So I'll start with Kevin Bacon. Well, that's not a good start. That's my SVG. I do have a line between them. Maybe gray is not a good color. Oh, sorry, it's the stroke. Well, let's that's not ideal. Any ideas what's going on here? So it seems like, so I'm not, oh, okay. Oh, good. That's an easier problem to fix than what I thought it was. Okay, yeah, much better. Okay, cool. There we go. Although, I think we're missing so what do you think is going to happen when I drag this? What else? What do we need to do to fix that? So I need to do all this when I drag, right? So we're going to do that. So we're going to pull this out into its own function. And we're just going to apply this to all the edges that we have. Okay. And then, so I can, so here, I could either say like, I could write, you know, update edges, edge positions, enter, or I can use the call function. And so this is just going to pass the selection to this function for me. So this should do the same thing as we just had. So great. And then now we just want to call this when we drag. We just want to call this on all the edges. So here, I'm just going to select my canvas, grab all the lines in my canvas, and then I'm going to call this and all this. So every time I drag, I'm going to update all the positions of my edges. I could try to like reduce the number of calls I make by being more selective and only update the edges that are connected to this node. That's going to be kind of tricky here. How come? It's going to be tricky to find which edges are associated with the node that's dragging. Since my edges are now one directional, right, I have to look at both endpoints to figure out, like, is it associated with the node I care about, right? So as I've stored my data, it's kind of a pain. A more efficient, how could I maybe be more efficient with this?
You store a reference to the line.
Yeah, I could store like either a reference or like an index of the edge on both nodes, right? And then either one of them could update it, and then, you know, that might be an improvement. But not a big deal here. So with this, I can now, I got my graph of A Few Good Men, and I can see that that is distinct from my Frankie Muniz movie. So pretty cool, right? Right, so now we have a potentially much better graph layout algorithm than the force-directed or the shell layout, which is the super complicated, long-trained neural network layout algorithm of whatever is in the user's head. So the manual approach could be can be a lot better. Okay. Cool. Questions so far? All right. So the last thing we're going to add is we're going to add a simulation element. So we are going to add a force-directed layout to this, so that the nodes naturally spread apart, and they lay out automatically, but I can still kind of edit them. Yeah.
If we wanted to add like the movie title to the edge,
Mhm.
would we kind of do something we had a group and then apply?
Yeah. And then you probably want to do something clever where you look at the slope of the line and then apply a rotation to the text. So yeah, doing that would be a little bit of a pain, but you could totally do it. Yeah. It'd just be a little bit of trick. Another thing you could do is you could add like tooltips. So you could put like when you hover over the line, then it displays. That might be that would be like a less messy thing to do it. Another thing you could do is a linked view. So you maybe pick the nodes that you want, click the nodes, and then you'd have another view that shows the path. So with information about the various movies along the path or something.
Make the line the actual text.
You could do that too. Yeah, I think you could. You can do any sort of transform to the text. So you could write it out and then scale it so that it is the size of like the right length. I think it would be a little bit difficult to read, but you could do that. Yeah, all these things are possible. You could use the database to grab the title poster and scale that into the line, so you'd get a smushed version of the poster for A Few Good Men. That's all the cool stuff you can do here that you could never do in Matplotlib. Right? That's actually, I mean, in theory you could, but nobody wants to do that. Matplotlib is just a nightmare. So yeah, any of these ideas, right? SVG is super powerful. You can add all sorts of animation and effects and whatever you want. And D3 is a pretty good way of working with that stuff. All right, so the last thing we'll do is we'll add a simulation, so that we get force-directed graph and all that stuff. So we're going to do make a force simulation. And then in here, we're gonna like update. We're gonna change the forces, change the nodes, that kind of stuff. So the first thing we'll do is we'll set what the nodes are. So again, this is the simulation. It takes an array of objects that have X and Y properties. And then it updates those properties. It doesn't position anything for you. That's got to be manual. Right? So you have to say, okay, how do I take the X and Y out of the simulation and change that into just something I see visually. But the nodes we're going to work with are our active nodes. And then we'll start with just two forces. So we'll add a force that just tries to pull things towards the middle of the screen. And so this is just we're gonna just pull towards width over 2, height over 2. And then we're going to push everything apart. Okay. So we'll start with these two forces and we'll see what goes on there. And then we have to say so this is just going to update the x and y nodes of the velocities a bunch of times. Each one of those steps is called a tick. So each time there's an update from the simulation, we can say, okay, what should we do? And usually that's we update the positions of stuff. Okay. So we're going to say on a tick. So what should we do each time step? So we need to basically update the positions of our circles. And then we have to update the positions of our lines. So I'm going to copy and paste this stuff, which I know is bad. It's just different enough that I'm not going to be bothered to make it generic. So I'm going to select the grab the groups first. And then within the groups, I'm going to grab the text and update the position. Does anybody know why before I could just do d.x and here I have to do this function? So I grabbed this code from the dragging section. So how many nodes was I dragging? I was just dragging one node, so I could just look at, there was only one bit of data. Right now, with the physics update, all of the nodes are moving, so each one is going to be something different. Okay. So I'm updating the circle positions and the text positions. So the x and the y of my active nodes are just going to change based on the simulation. Okay. And then, yeah. Okay. And then I'm going to call restart to make stuff happen. All right. So unless I screwed something up, I should get nodes that are kind of pulled towards the center but pushed apart from each other. And I don't think the parameters I picked here are great, but and the name I wrote down is wrong. And that doesn't seem right to me. So it looks like my edges and my text are getting updated properly, but maybe not everything else. Nope, that would be why. Updating the wrong circles. Okay. And maybe we'll just add one more thing, so we can see when we're ticking. So you can see it's ticking, a bunch of times. And it doesn't tick for very long when I add new ones. There's something I don't fully understand about what's going on when it resets. And when I think it automatically turns off the simulation once it thinks nothing's happening. So you can see things are being pulled towards the middle and repelling each other. So the next thing we'll add is some spring forces. So the edges should pull things closer together. Right, so we'll throw on where's the link? And this takes the list of the edges, which is going to be my active edges. So this is, yep. And finish work. So now we have some spring forces. Again, I don't know why it stops ticking when you add new stuff. And then the one other thing I'll add is after we drag stuff, like the simulation stops running, so we'll just add one more. So when we stop dragging stuff, we'll restart the simulation. So you can see the centering force is keeping everything stuck in the middle, which is kind of nice. And I don't know why these other ones are. So just to show a slightly larger scale example of basically the same thing we're doing here. This is the Les Mis data as a graph. Yeah, so it's laid out using basically the same stuff that we're doing. So, yeah, that's a little bit more in depth with D3. So we added we added some interaction with the dragging. We added some more visual stuff, so we used slightly more complicated SVG stuff with the groups to put stuff together. We added the links, and we added some automated layout stuff. Again, I assume there's like a function call that I'm missing somewhere, which is why it's like stopping right away. So I'll look into that. Hopefully have a better answer for that tomorrow or on Tuesday. Yeah, hopefully you can kind of see the potential of interaction to understand and explore data in a way that like a static matplotlib graph can't really do. But the flip side is the static matplotlib graph is one line of Python, and here are like really basic thing. We're already up to like 200 lines of JavaScript. So you know, it's not free, but we can customize it and do all sorts of crazy stuff. So D3 has a ton of other things built in. So the one I didn't mention yet is transitions. So you can say like, you know, transition. You can do like style transitions. So you can say, okay, set the color to red and then blend it to blue over the next 1 second, and it'll like interpolate. You can have things fade out and then disappear. You can have things like move. So there's all sorts of cool stuff you can do with that. And there's a whole bunch of other like plugin libraries. So there's a bunch of other force stuff you can do, and Yeah, a lot of stuff in here. So any questions about this stuff? How to use it? What you might do with it? All right, cool. Yeah.
This was kind of an old library right from the beginning, right? What's
So this is, it started in 2011. So I looked into this. There does not seem to be something that has totally superseded it that is as flexible and powerful. So there are a bunch of like specific libraries for drawing different types of graphs and that kind of stuff. I don't know of anything quite as like powerful for just general purpose visualization. There's commercial tools that are kind of more like, again, more like a little bit more like Matplotlib, and they have stuff kind of built in that you put together. But yeah, as far as I can tell, D3 is still kind of the like Swiss Army knife JavaScript visualization library. Cool. Well, enjoy your weekend. And on Tuesday, again, we'll have a guest lecture. I think last summer this seemed to be like people's favorite lecture, so get pumped. It'll be good. And then Wednesday we're off.
Is lecture during class or after?
During class. All right. Cool. See you on Tuesday.